Yeah, I think she joined.
Okay.
Yeah, you can start recording.
Yeah, I just
We
started. It's recording.
fine, fine. Yeah. Uh, Yesterday, most of the thing we saw, like higher order functions, function variables, then higher order functions. Then we saw collections and how higher order functions are applied on collection. Mainly we saw map and reduce higher order functions. For each is also one more higher order functions. So most of them in Scala or Spark especially, you will see everything is written in most of the time higher order functions. Whatever problem we try to solve are done through higher order functions. So it will be good so that you practice on more higher order functions. So collections, we saw collection as a list. List was a collection. Then we saw vector, which is more efficient than the list because random access is always best when we do it as a vector because it is in the form of a tree structure. It is in the form of a tree structure, and the data access is always it takes very less time to access any random data in the list. Then we saw some examples on map. We saw reduce. We also said that Scala is immutable by default, meaning Scala collections are immutable. Scala collections are immutable. If we try to add something to Scala, or if we say we have val x equal to list 1, 2, 3, and 4. If you want to say x val y is equal to x, is it? If you do append, this is the append operator. It will append at the end of the list. This is a append operator. It will append at the end of. These are like cryptic. You need to remember. Mostly, I sometimes forget what is the append operator. What is how to add at the front of the list. You need to just remember these things. Operators. These are new operators that will operators that you see. Not operators. Sorry, these are all functions. Actually, these are all functions. So these are new things you will see. You need to just remember those things, or you need to get used to it. So it will append at the end of the list. So whenever we do append, the earlier list is not modified. If you print X again, it is still 1, 2, 3, 4. It did not modify the list because it is immutable. This list is immutable. It created one more list and assigned that one more list to Y. That's what I meant as Scala is by default immutable, means the collections are immutable. Nothing gets changes. Nothing is modified. A new list will be created and that list is assigned to Y. And this is the append operator. Sets we saw, and also we saw that we saw different collections like list, vector, sets, and map. In each of these collections, we had a apply method. Apply method is a unique kind of a method, but similar to all other, the syntax, everything remains same as a regular traditional method, but only property of that is you need not specify the name of the method while calling that method. You need not specify the name of the method while calling that method. And we saw that using that, each collection has its own implementation of the apply method. We saw list uses to access the fields, set uses to access check whether the element access is there or not, and map uses to get the value for a particular key. There are different methods or a different implementation of the apply method based on different collections. And we also saw this reduce method. We also saw this map method. Map is like a transformation. Reduce is like a take a whole collection and reduce it to something, and it takes two parameters. One we can call it as accumulator, the second one you can call it as an iterator. Next we map methods. We saw these were all simple or collections. Most of the time we can say as these collections. And yeah, some more examples. We have collections of collection. This is also possible. Inside a list, it has two elements. First element is again a list. We can have a nested list as well. We can have a collection of tuples as well. Any type of collection is possible. Hence, collection is list is of a generic data type. It takes data of any data type. So it is a list of tuple where first element is a character, second element is an integer. So these are all different ways of creating a list. That's all. Need not. We can go through this. Not much in-depth details are there. Just an examples are there. These are all simple examples on collection list. And we want to say one more concept here is nil. This is how we represent an empty list. This is how we represent an empty list, or in this way. Either this is the empty list, or either this you can use list with open bracket and close bracket, or nil. Both will represent an empty list. There is one more operator called cons operator. This also is used in the creation of a list. This also is used in the creation of a list, as well as it is a you can say add an element in the head, add the element at the first. We can also say that. Let's see, earlier we created, this is also a good concept, and those things are being used in pattern matching. The const operator is being used. Operator in the sense it is a function actually. Operator is nothing but actually all those things are functions. Val x we say equal to list 1, 2, 3, 4 and 5. One second. Yeah, this is one way of creating a list. There is one more way of creating a list is val y I can say equal to 1 double colon 2 double colon 3 double colon 4 double colon 5 double colon, and then I will say nil. This is one more way of creating a list. This is called a const operator. Const operator. Earlier I had said that when we did val a equal to 10 and val b equal to 20, then we said val c equal to a plus b. When we did this, I said that plus is a method which is associated with the object on its left hand side. What actually meant is c equal to a dot, we are calling the method plus, to which we are passing the parameter b. This is what I said. We are calling plus method on the object on its left hand side, a. So this is what actually it returns. Similarly, the reason I stress that is because we have these kind of methods which has these operator methods. If at all any operator method that ends with the colon, if any operator method that ends with the colon, this is kind of a generic rule you can remember. If it ends with the colon, that method is always associated with the object on its right hand side. This is a method here. If at all it ends with the colon, then that method will be associated with the object on its right hand side. The way this evaluates is, the the way this evaluates is nothing but that I can say equal to first nil will be there. On that nil, we are calling this const operator method to which we are passing 5 as the input parameter. So if we do this, we'll get a list with 5 as the object, with list with 5 as the first element. On this again, we'll call this operator and pass 4. Similarly, we'll go on do this, pass 3. This is how it evaluates. Pass 2, then 1. This is how the list is created. This is nothing but a append operator, or you can say add element, not append, add element at the head. First time empty list is there, add an element to the head. So 5 becomes the first element. We get a list which has one element 5. Then again we add one more element to the head. So next we get 4 and 5 with 4 as the first element. Next we add one more element, then we get 3 as the first element. Then we add one more element, we get. This is one more way of creating a list here. Only thing is, you have to remember this. If at all a method, pardon, was there any question?
Pramod, can you hear me?
Yes, I can.
Yeah, Lekha here. So nil is always necessary, is it, while creating a list?
When creating a list,
is nil always necessary?
Nil is always necessary, or nil or any other list. If you give here val 1, suppose that's a good question actually. Let me say val, I will say val L equal to, I will say 1 colon 2 colon 3 4 something. Now what happens? Based on your question, we are not giving a nil here.
Yeah.
Yeah. What happens now is, we know that if this is a method, colon is a method. If it ends with the colon, if that operator method ends with a colon, that method should be associated with the object on its right hand. 4. But 4 is an integer. 4 does not have a method with double colon. If you see, 4 does not have a method with colon, so it should give an error. It says that colon is not a member of the integer. It will try to do that, but it will be giving an error. So you need to have a list at the end, either an empty list or something, some list. So now it will work. Was that clear?
So list is empty in the end, correct?
Right. We are giving an empty list, that's all. To that list, on that list, this method is being called. This function.
Yeah. So how will it decide that 1 is the head, but whereas 4 is not? 1 becomes the head, right?
You mean to say 4 becomes the head?
No, in this case, which is the head?
1 is the head.
How does it evaluate?
How does it evaluate?
Yeah, correct. Yeah.
Yeah, it's evaluates from here. Initially, it will call list, empty list dot. It will call this method. That empty list will call this method, to which 4 will be passed as the parameter. So if you see this, now a list will be created with 4 as the element. So now what happens? We have list of 4. On that, one more method will, that method will be called, to which we will be calling 3, passing 3, sorry. So it will create one more list with 3 as the element, head of the element. Every time it will keep on adding element to the head. Next we got list of 3, 3, 4. To that, again, this method will be called and 2 will be passed to that. It goes on in this fashion. It will be evaluated from the right because this method will be associated with the object on its right hand side. Hence, it will be evaluated from the right hand side. Only if an operator or a method which ends with colon, those operators, I'm not sure which all extra things are there. This is one I found. If at all it ends with colon, it will be associated with the object on its right hand side. Yeah. Was it clear, or you had a totally different question?
Yeah, it's clear. It gets
Okay.
evaluated from the right, objects gets added to the head.
Right.
Yeah, okay.
You can also assume that this is an operator or a method which adds to the head of the list. Either way you can imagine. One is like we have val L, I will say L equal to list 1, 2, 3, 4. Then I said val LM equal to L. I used one more parameter, colon method, colon plus. I did a 6 here, suppose. If you see, this will append to the list at the end. To the tail it will append. You can imagine this as a append operator and colon as a operator which adds element to the head. This method adds at the end. This method adds at the first. You can imagine in that way. Here, since it does not end with the colon, this method does not end with the colon, hence it will be associated with the object on the left hand side. That's the reason we are giving list in the left hand side and then the integer on the right hand side. Only if it ends with a colon, then the list has to be on the right hand side. You need to remember that when we are doing plus or this. There is one more operator. These are like, you need to remember these kinds of new things Scala has used. There is one more. We have val m and n. We have L is one list, m is one list. We can have val n equal to L colon and m. It will append the list actually. It will append the to list and give you the result with 3 colons. Since it ends with the colon, it is similar to m dot this colon method is called, and L is passed as an argument. Since it ends with the colon, this method will be associated with the object on its right hand side.
Yeah, but why are we giving 3 colon?
3 colon is if both are collections, both are list. We are not appending an element, we are appending a list altogether.
Oh, that's the syntax?
Yes, yeah, that's the syntax. It is cryptic, yeah.
Okay.
Yeah, these are all things you need to just remember, or just Google it whenever you want to add to list or append to list. Just you need to Google, and it's hard to remember again. You need to just Google it.
Okay. So these operators are used only for list collections, or the
Yeah. Yeah, it is only for list collections. There are some other operators for different things. If you see, this is also operator was used to add a element to a map collection. Arrow mark
Mhm.
was used to add an element to a map collection. So you can always do this list L dot, sorry, L dot, and tab on that. You will get lot of, if you see, these are the methods on top of that, plus plus. Even I don't know what does this mean. Probably I have to Google and check. It's hard to remember. There are apply
Oh,
method, else. All these methods are available. These are all the methods on top of list. Yeah, the reason I explained this const operator is just to explain that whatever is if it ends with a colon, it is be associated with the object on its right hand side. And one more reason is using this const operator, you can all actually do a pattern matching. You can actually do some pattern matching that we learned in the match expression. That we learned in match expression. Those things come in handy if we use this const operator. We'll see those examples as well.
okay.
As I said, this is nil. The same thing, list arithmetic. Yeah, these are some of the higher order functions if you can see on collections. These are higher order function. Filter. Filter is a higher order function that takes a function and input is a parameter from each element from the collection will be passed as an input parameter to filter, and this is the logic we are giving. This logic seems simple, right? Writing this way, it is more readable than here. Filter all the elements of the collection which are greater than 18. This is actually higher order function, and this is a function logic that we are passing to this higher order function. This is how usually we write it. We can give any logic here. We can give any logic here. So, but it has to return a boolean. Filter means it has to return a boolean. If you go and just put it here, we hover on this, has to, if you see, the return value of the function is a boolean here. Filter is a higher order function which takes a function, and that function takes some element, and the return value of that function takes a parameter of type any type and returns a boolean. The function has to return a boolean. Only those logic can be applied on filter. Only those logic can be, again, filter is a higher order function. That's what we are trying to, if we execute it, it will, so it will filter all the elements which are greater than 12 and give you a list. This is the use of all higher order functions. We can give any logic here so that we can filter the data. Similarly, there are other things. If you want both the results, here we only got a list which were greater than 18. We can get both the results using the partition API, partition higher order function. All the all the elements which are less than 3 will be in one list, and all the elements which are greater than 3 will be in one more list. Both the lists are returned as a tuple here. Both the list will be returned as a tuple. These are some of the higher order functions that are possible on collections. If you see, we are doing a partition. All the elements which are less than 3 have come into one list. All the elements which are greater than 3 are come into one more list. And these two lists are returned as a tuple. A tuple with first element as a list and second element also as a list. So you can, there is also a sort by, where you can give how you want to sort by the collection. Sort by is again a higher order function. Sort by is again a higher order function, which takes a function and that function sorts the data by size. We are giving by size here, which takes each element and gets its size, and sorting is done by that size. If you see apple as size 4, it will come first, and sorry, 2 as size 2, it will come first, and apple as this. We can also sort by first element of the first character of the string. We can also sort by first character of the string. In that case, again, apple will come first because A is first and T is the comes last in the alphabetical order. Hence, it has sorted with first character of the collection. So you can give any logic here the way we want to sort the collection. It is all possible because of higher order functions. These are all higher order functions. Most of the things are higher order functions in Scala. I think in Java 8 also, they have written most of them, taken all this concept from Scala and put it in Java. They are also having higher order functions there. But I think it's called lambda expressions, as I'm not sure whether higher order functions is lambda expression or function variables are lambda expressions. I have a confusion, but they have taken everything from here, Scala, and implemented in Java 8. Yeah, there are some more examples here. Take right, drop right. Take right means from the right, take 3 elements. You have a list. We'll say val L equal to list 1, 2, 3, 4, 5, 5 and 6. We have this. Then I will say L dot take right. I will say 3. From the right, it will take 3 elements and give the result. If you see, it took from the right side, it took 4, 5 and 6 and returned that as a list. There is also drop right, drop left, take left. I think not take left, sorry, take right. Take 3 will take the first 3 elements and return as a list. That's all. Similarly, we have drop right. It will drop the last 3 elements and return the rest of the elements. It dropped the last 3 elements and return these as the elements. Similarly, we have drop. 3 means first 3 elements will be dropped and rest of the elements will be got. Rest of the elements will be got. 4, 5, 6. As I said, the original collection will not be modified because it is immutable. It will do one more collection and that collection will be returned. It will create one more collection and that collection will be returned. Original will still remain as it is. These are some of the APIs that can be used on collection. Yeah, collect we'll see it later because it is a different type of a function actually. Collect is actually a function which is a different kind of a function. We need to know about partial functions. We learned about partially applied functions. There is one more concept called partial functions. We'll see it later. Hence, we'll see the collect API also later because collect API is a partial function. we know what is a flat map. Flat map is similar to map, but it will unnest the nested structure. It will unnest the nested structure. Let me check here. Let's take a value here. Val list equal to, we have a list and I have two elements, milk, tea. Then I will say black coffee. Now this is a string actually here. This is a collection of two elements. This is the first element, this is the second element. But now I want the whole data to be in this format. Yeah, I have a list which has two elements, black coffee, two strings. Now I want the result to be as this, while r equal to, I need a list of four elements. Milk has one element, tea has one more element, black has one more element, and coffee has other element. I want the data to be in this format. So how do I do that? So this is how we are trying to do. We have this, then I will do val x equal to l dot map. I'm mapping, then I'm saying for each element, split that element with this. For each element, split that element on the colon. This is the first element, this is the first element. I'm splitting this by colon, comma, sorry, by comma. So what will I receive? So what will I receive? Here is an array of, the split will return an array for us. The split function is I think it is available also in Java. It returns just a array of whatever we are splitting. First it takes this element, it splits on comma, and it returns an array with milk as the first element, tea as the second element. So, but we did not want in this fashion. We don't want in this fashion. We want, how do we want the result? We want each element to be a element in the list. We don't want a nested list here. So what we can do here is we can flatten it. There is one API called flatten. Once we do a flatten, it gives in this fashion. Flattening is nothing but unnesting the nested structure. Here we have a nested structure, list of array of string. We are having list of array of string. It is a nested structure. Flatten will unnest that. So we need to use map and flatten. So instead of that, there is one more API called flat map. L dot flat map, which will do map and flatten automatically. Which will do map and flatten automatically. So it will give you the result in this fashion. So flat map is also a higher order function, which is a combination of map and flatten, which is a combination of map and flatten. Map will just do the transformation. Flatten will unnest the nested structure. It will unnest the nested structure and give a single structure. That's all. Instead of using these two separately, we have an API called flat map. We can use that flat map. I hope that was clear, right? Flat map.
Pramod?
Yeah.
Can you repeat? Can you show the screen where you?
Yeah.
Yeah, this.
Let me explain once again.
Yeah, thank you.
Yeah, we have suppose val x equal to, I'll just take milk comma t. Okay.
So this here
Milk,
milk
pardon?
and tea is so here milk tea is what? Is a key value pair or it's like just
No, it's just a string.
okay.
It's just a string. Just we'll try to apply val y equal to x dot split based on comma. If you see, split is a API on a string. Split is an API on a string which returns which separates based on the comma that we have passed, because comma is the separator here. Usually it will be used in comma CSV files. To parse the CSV files, we'll be using usually the split API. Is comma separated value, those files. So we are separating the value as this. The split will return an array. So, but in our case, it was in this fashion. Val L equal to, these things was in the list actually. This is a string. We had a list with two elements. We had a list as two elements, and we want it to be, what happened? Something happened, right? Okay. Just the way it is represented. That's all. I thought it already made it as a whatever the result was required. It is just a representation. It is still, the first element is this, second element is this. We want the result to be in this fashion. We want the result to be in this fashion. Four elements has to be there in the list, not just two elements. We have to separate whatever is there in the comma separated value. For that we can use, we take val L or M equal to, I will say L dot map. I will call a map higher order function and transform this function. Transform the data here. We are transforming each element to some other element. Transforming to each element to some other. We'll take each element or underscore, I can say, and split on that with the colon, comma, sorry. When we do this, for each element we'll get an array. For each element we will get an array, as we are doing a split on each element. The map, for the map, each element from the collection will be given as the parameter. Each element from the collection will be given as the parameter. Here each element is these things. There are two elements. The map function will be called 2 times or loop 2 times and get the collection. For each parameter or for each element, it will do a split. Hence, we are getting array of milk, tea. For the second element also, we are getting black and coffee. This was our first element. Using split, we got an array. This was our second element. Using split again, we got the array. But we don't want a nested list here. We don't want a list of an array. We just want a list. So that's why we will do flatten here. Flatten, what it will do is it will unnest the nested structure.
Pramod?
Yeah.
So on a string, when we did split on a string, we got array of elements, right?
Right.
So on a list, we can't do a split, so we're using the higher order function map, is it? This is...
Yeah, we use the higher order function. Here is the reason we are trying is we are trying to explain the flat map. Flat map, what is flat map? We know what is map. Map is just a transformation. Here we are trying to explain what is flat map. Flat map is similar to map, but it will unnest the nested structure.
Okay, we can't do L dot split, correct, is it?
L dot split. L is a list. The split API is available only on string. This is a method available on string only.
String only, okay.
Yeah. List does not have this method. So we cannot do it on a list.
Okay. So when we declared L equal to list, milk tea in within quotes and black coffee within quotes, it got printed as okay group. Okay.
Come again, I did not get you.
I'm thinking of what map is actually doing. Map higher order function.
Map higher order function is just transforming this string into an array. It transforms this string to an array. As I said, map is a function which does a transformation.
Yeah.
Map is a function which just does a transformation. We saw this. Each element will be transformed to some other element. Here it was a string. It transformed into an array. Here it was string. Each element it transformed. So that's the use of map. Map higher order function. The use case is transform it to each element. The number of elements remains the same. Number of elements remains the same. Each element will be transformed to some other data type, or it could be the same data type, but some logic could be different here. Based on the logic, it will transform to some other thing. Here our logic was split. Our logic was split. As a result, it transformed into an array.
Okay.
Yeah, but this is not what we want. We want all the elements in the only one list. We have a nested structure here. List of array of string. We don't want that. We want a single thing. That's what we use flatten. The use of flatten is it will unnest the nested structure. It will unnest the nested structure. So instead of using map and flatten, we can directly use flat map. We can directly use flat map and it will give the same result. So that is the use of flat map. Map will transform into each element to some other element. Flat map transforms one element into more than one element, one or more than one element. Flat map will transform one element to one more element. There is one-to-one mapping. If you see flat map, there is one to probably more than one mapping, one or more than one mapping. It may result one element into more than one element, or equal to one or more than one element. That's the property of flat map. If you see here, this one element got transformed into two elements. This one
Okay.
element got transformed into two elements. 1 second. Sorry, sorry for that. Yeah, that's the use of flat map. That's the use of flat map. Unnesting the nested structure. Any? I hope the doubt was clear. Any other question?
The functionality was clear. Uh, in real scenario, we would get data like this, is it? Where there is a group of data
Right,
and we want to
right.
filter it. Oh, okay.
Right. We will be using. You can use this flat map in that case. We may be getting this kind of data. We can use the flat map. There are use cases with. I think I don't have an example, but I have seen examples, such flat map examples. You will be having those use cases.
Okay.
So there are some more reduce functions, higher order functions. These are all higher order functions. Exist is a higher order function on collection. This is a collection. It contains true, false, a collections of Boolean values. It is a collection of Boolean values. Here we are checking for all is a higher order function which checks whether all the elements of a collections are true. Any checking can be done. For all is an API or a higher order function which checks for all the values for a certain, is it equal to some certain value, whether all the values is equal to some certain value. We are checking whether all the values are true here. Obviously it is all the values are not true, some are false values. Where one is a false value, it will return false. So we are calling it as a reducing list here. Means we take a collection and return a single value. We are taking a collection. If you go back here and see map, flat map, we took a collection and transformed into one more collection. One-to-one mapping was there in the mapping. Flat map, one-to-many mappings were there. One-to-many mappings were there. So we took a collection and returned a collection. Flat map and map takes a collection and transforms into some other collection. But reducing means take a collection and reduce it to single element. In case of, if you see, if you do any kind of analytics, if you want to do any kind of analytics, we take a whole column and we aggregate it. That is nothing but aggregate and give a single value. So that is all about reducing a collection. We count, we do a count, we do an average, we do a sum. All those things are kind of reducing a collection. So similarly, these things are taking a collection and reduce into a single value. Similarly, it also checks whether any element is equal to false. Validation dot exist is a higher order function. It checks each element and checks whether is equal to false. It does not say that all the elements should be false. It checks whether an element exists whose value is false. So these are all some of the higher order function which reduces the list, reduces the collection, you can say. Similarly, we have reduce. We already saw what does it do. So these are some of the APIs you can try out. Exist. All these are reduce kind of a higher order function. These are all map, flat map, for each. All these are higher order function. We also saw partition. That is also a higher order function. Sort by is also a higher order function. Filter is a higher order function. Usually we'll see in Spark filter, sort by, and map, flat map, all those things, reduce by key. All those things we will see in the Spark also. So they have taken that same Scala APIs, map, reduce, filter, and they have implemented that for the Spark. That's the reason we are learning initially how this higher order function looks like. Because in Spark we will see only the higher order functions. Next we have pattern matching with collection. As I said earlier, pattern matching is much more powerful than the switch cases in Java or C or C++. In Java, C or C++, we will be matching, we are using switch case only to match the primitive data types. We'll check whether it is an integer, we'll check whether it is a double or string or character for primitive patterns, primitive data types. But here it is much more powerful. We can apply it on the collections as well. We can apply it on the collections as well. Let's see how to do pattern matching on collections. So this is the normal case that we did earlier. This is a collection. Here it will be evaluated. We know that a collection of head will give you the first element of the collection. So this is the normal case. We are actually passing the first element, which is 500. We already saw 500 being passed, a numerical value being passed to a pattern matching. We pass that 500 here, we bind it to X using the value binding. Then we are checking whether X is less than 500. Then whatever is on the right side of this arrow mark, that will be returned from this match block and assigned to the messages. This we already saw how it works. Now we'll see what happens if we pass the whole status itself. It can, how do we match it here? This is how do we match here. As simple as it looks like. Pattern matching on the collection. Its statuses, yes. It's a collection which is 500, then 400. We have a collection this, we have this. Actually we are passing the whole collection here. We are passing the whole collection here. And the collection is binded to X here. X is an identifier. X, the value that is being passed. Status is nothing but this collection. That value 500 and 400 as a collection will be passed to the match block, and X will be binded to that collection. Now we are checking, since X is a collection now, we are checking X contains 500. This is how we do the pattern matching. This is how powerful that pattern matching is, but it looks very simple. We are X contains, we are doing, we know what is this. X contains means X is a object, on that we are calling the contains. We can always use a space and call the operator or a method. We also saw this how to use this syntax also, and pass 500 as a function parameter and check whether X contains 500. If it is, if this pattern matches, we'll get whatever is on the right side of the arrow mark, that will be evaluated and returned from the match block. It will be returned and assigned to message. So this should give the first one has error. It should return has error. This is how we make the pattern matching in collections. Similarly, we have pattern matching. Yeah, this is what we saw. This is also could be possible. Here we are checking directly, we are checking the collection. Directly, this means match the pattern. Pattern matching will hold good if whatever we pass to the match block, should contain 500 as the first element, 404 as the first element, 500 as the second element. Only then this matches. We are explicitly saying that this pattern matching has to validate. This says that it will be true only if we pass a list, if that list contains first element as the 500, second element as the 404. This says that the list should contain first element as 200, the second element as 200. Only this pattern matching will hold good. In our case, this will hold good. If I In our case, if you do this, this second pattern matching will be matched. This will be matched. Whatever we pass here will be now. Actually, there is a concept called how it matches. Like you can imagine, there is one trick here. Let me try to explain that. We saw apply method. We have a list, sorry, val L equal to list. We have 1, 2, 3, 4. We also saw that L dot apply of 0 will, using this you can access the elements of a list. We saw that we need not have the apply method at all. We can directly say L of 0. Internally it will call the apply method. The compiler will call the apply method and give the element access. Also, I said probably did not stress that much. List is also kind of a apply method. Actually, it is 1, 2, 3, 4. Here we are not using new list. Here actually internally list.apply method will be called. List.apply method will be called, and it takes variable number of arguments, and using these arguments it creates a list object. So at the higher level I can say that apply is a method which takes fields or member variables and returns an object. In one generic way I can say that one form of apply method as it takes all the fields of a field members of an object and returns a whole object. Here if you see, it took all the members of the object and returned a list object. It took all the member variables, which are nothing but member variables and created a list object. Similarly, there is an unapply method defined inside Scala. There is one more unapply method defined inside Scala that takes an object. It takes object as a parameter and returns all its member variables or the field members and returns its field members as a tuple. You need to observe this. Apply you can assume as it takes all the members and returns a list object. Unapply method takes a list object as an input and returns all its members, giving all its members in the form of a tuple. Just remember this. To know more about this, I would recommend for collection it is actually unapply sequence. For collection it is actually unapply sequence method. To know more about this, right, I would recommend you to go through this PDF. I have already shared this. Go through this, but I will still explain here. a higher level, but this book is good. You can go through that. Just remember these things, whatever I'm saying. Apply method takes a field members of an object and creates an object. Unapply takes an object and returns all its field members. That's the generic way you can take about what is an apply and unapply method. So now we'll go back to our example. So what it happens here is whenever it does this, internally it calls the unapply method. It will internally call the unapply method. And from this list, it will return some variables, and that variables will be 400 and 500. So here it is not so obvious. Going forward, it will be more obvious. Going forward, it will be more obvious. Here you can assume we are just matching. A list is being passed that is being matched to these things. Like we matched a simple integers earlier. We actually matched the Boolean values. We actually matched the simple integers, strings, all those things. Similarly, you can assume a whole list with is matched here. Status is nothing but 500 and 404. The whole thing is done a pattern matching here. The whole thing is done a pattern matching. Exact values are being matched here. We'll see also variable binding inside the collection. That's when that unapply sequence makes sense for you. We will see value binding inside the collection. We saw earlier value binding for the whole collection itself. The collection itself was binded to a identifier. We will see a value binding for each element of the collection. Next, we will see that in that case, it will make sense what is the unapply method being used. So we have, if you see here, this is one more example. This is where that unapply method makes sense for you. Yeah, what it means is, again, we are passing the status, which is a collection. We are passing it to the match block, and we are pattern matching with this. We are pattern matching with this. This pattern matching, how it happens is, it says what it means here, a collection whose first element is 500 and it should match a collection of two elements. It should match a collection of two elements with first element as 500 and the second element could be anything. First element as 500 and the second element could be anything. That's what it says. A collection with two elements, exactly two elements, and first element could be 500. First element should be 500 and second element could be any number. Second element could be any number. That's how the pattern matching works here. Here, whenever we do this, unapply sequence method will be called. Here, unapply sequence method will be called. Here, unapply sequence method will be called, to which this status object will be passed. Here, internally, this will call unapply method, to which status object will be passed. As I said, unapply, what it does, it takes an object and returns its fields as a tuple. So that tuple will be binded to these things. That will be binded to these things. So 500 will be 500 itself of this status, and 400 will be binded to X. 404 will be binded to X. As I said, it will take and it will return a tuple of elements. It will return a tuple of all the elements of the collection. All the elements of the collection. And that will be mapped to this. That will be mapped to this. As a result, X will be mapped to 404. X will be mapped to 404. That's how it works. So let me show you a glimpse of that, how it works here. This book explains it very well. It says extracting sequence. It says extracting a sequence. So whenever these things happen, actually internally this unapplied sequence will be called, to which the object will be passed and it will return a option of it returns a sequence, not tuple, sorry. It returns a sequence. Sequence is a collection, and that collection will be mapped. I hope you got how that pattern matching actually works internally. Internally, actually, unapply method will be called. It will take this as the object. It will take whatever we have passed as a whatever we have passed to the match block, that will be taken as a object to that unapply method, and it will return the sequence of all the elements. And that sequence of all the elements will be mapped to these things. 500 will be 500. X will be binded to 404. X will be binded to 404.
Pramod?
Yeah.
Lekha has replied that she has a power problem. She is not in the call now.
Oh, is it? Okay.
Yeah. Okay, no problem. Anyway, it's almost an hour and a half, right? We can catch up on Monday.
Okay. Okay. I can listen to the recorded session from where I left. I will sync up on Monday with clarification if any. Okay.
Anyway,
So,
we can
do you
start.
want me to continue?
That
Because she said that she.
no problem, Pramod. Even I need to study, catch up the where we from the past two classes, right? This will be
Okay.
fine. We
Okay.
can
Okay.
stop it
Fine. Fine.
here.
We can stop it here. Yeah. No problem.
Okay.
But this concept was clear, right?
Yeah, yeah. I
How
understand the
this
concept.
pattern match works.
Uh,
Yeah. Yeah.
And meanwhile, as you referred, I'll see this book also.
Sure. Sure. But don't try it now. It
No,
will be a
yeah.
bit confusing.
First,
Try
I'll start
first
with the
the learning start.
initial. Yeah, initial
Learning
itself.
Scala. Then the Neophytes Guide is very good book. It gives the internals of how things work in Scala.
Okay.
Yeah, you will get a good hands-on, or will get a understanding why these things work, how internally things work in Scala.
Okay. Okay.
Yeah,
Okay, sure, no problem. Monday, maybe in weekend, I'll sit and practice the initial few classes topics.
sure, sure. Yeah,
Okay. Okay, Pramod, I'll upload this video now.
yeah, yeah. See you
Okay.
then.
Thank
Thank you.
you.
Happy.
Thank you. Yeah. Happy weekend too. Bye.
Bye.